study for type 6 having a combination of resistance, inductor and capacitor, and the plus one is it is having a steady state condition. That is a point to be remembered. So let's start with the basic steps for it. At t equal to 0, 0 plus and t greater than 0. I need to find I, di by dt and d square upon. So let's start with t equal to 0 minus condition. When I say t equal to 0 minus condition, so I have a voltage source which is 40 volts, series, a resistance 20 ohms, and having a capacitor. Since the condition says it is a steady state condition, that means my capacitor is fully charged. So it cannot accept more current. If it cannot accept more current, that means the circuit is. So the current flowing across this network will be but obvious 0 because circuit is open. Why you made it open? Because the capacitor was fully charged. How much charge will it be? 40 volts. So the voltage across capacitor is nothing but 40 volts. So that's your first condition, my dear friends. So let's go for second condition. At t equal to 0 plus condition. Let's draw the circuit for the same. At t equal to 0 plus condition, so you have an inductor. An inductor initially it will oppose the current, and you have a resistance and you have a capacitor. And capacitor, it was fully charged, so since it was steady state condition for capacitor, so for capacitor you will be drawing the voltage source which you obtain the value as 40. You will be finding the current. In this circuit, the steady state condition was only for the switch point 1. At switch 1, there was only capacitor connected. Inductor is connected at switch 2, so don't get confused. Steady state is only for capacitor for whichever component which is connected for 1. So capacitor is fully charged, you have to make it open, and the voltage value is the value for a capacitor. So when I say about inductor, so switch 2, I just connected with the inductor. So inductor initially it will oppose the current, right? It's full of resistivity. The circuit will become open. And for capacitor you replace with 40 volt because it was steady state condition. So in this case, your current value will be 0, 0 plus, since circuit is open. And the voltage value for capacitor is nothing but here 40. So that's your second case condition. So let's go for third case. At t greater than 0 plus condition. When I say about t greater than 0 plus condition, my dear friends, that means the switch is coming from 1 selected 2. So you won't be short and opening any inductor or capacitor. Your circuit will be as it is. So you'll be having an inductor, you will be having a resistance, you will be having a capacitor. Since your capacitor was in steady state condition, so you need to have a voltage source in series with your capacitor, that is nothing but 40 volt. Since it was connected as switch 2, it wasn't a steady state condition. When it came to switch 2, then only at that point the current started flowing through it. In capacitor, the current was flowing from 0, t equal to 0 minus. At that point itself it was in steady state condition. That is the difference in this case. So don't draw a current source directly over here. Think about it. When to draw a current source in inductor and when to draw a voltage source in series with a capacitor. This is very, very important, my dear friend. Okay. Circuit is closed. Now apply I of t. So in this circuit, my dear friends, you have a resistance. So apply your KVL. You should know the two formulas, voltage across inductor and voltage across capacitor, which we have already discussed. So it will be 20 I of 0 plus for inductor it will be L di by dt. So inductor value is 1, so it will be di 0 plus upon dt. For a capacitor value is 1 upon C. The C value is 1 into 10 raised to minus 6 integration I of 0 plus dt equal to the current enters into positive, it will be negative. I need to find di by dt, my dear friend, but I have an integration as well, so I cannot differentiate it to remove integration. This is nothing but beta voltage of capacitor. I already know the voltage of capacitor value at t equal to 0 plus, that is nothing but 40. So what you will be doing, you will be replacing this term by value of 40, which is nothing but capacitor value. So the equation which you will get it, term this equation as A. So 20 I of 0 plus di 0 plus upon dt plus 40 equal to minus 40. Shift everything that side, so you'll get the value for di 0 plus upon dt. I of 0 plus value which you got is 0. So the value which you will be getting is minus 80 amperes per second. That's the value which you got by solving. So we need to find value for I, di by dt and d square I upon dt square. For finding d square upon dt square, I need to differentiate A. Since it is having di by dt, so if I differentiate this, I'll be getting d square upon dt square. So let's differentiate the equation number A. So the equation which you'll get is 20 di upon dt plus this will be d square upon dt square 0 plus. Constant will be as it is. The integration differentiation will get cancelled, so it will be I of 0 plus equal to 0. So I need to find d square upon dt square, put the value of di by dt, put the value of I of 0 plus, we'll get the value of d square upon dt square. So let's solve it. Keep d square upon dt square on LHS side. Shift, since I of 0 plus was 0, so it is gone. This is minus 20 di 0 plus upon dt. Put the value of di, it will be minus 20 into minus of 80. The value will be d square 0 plus upon dt square. It will be 1600. The unit will be ampere per second square. That will be the term d square upon square. So that's what we had in next type. Let's have more types in this case to have a more clear concept for inductor, capacitor and resistors, how it behaves when it is arranged in a different manner, especially in steady state condition. Thank you so much. Signing off.